Once welcome back to MEME means Make Math Easy. Today I will take an important chapter limits for students 11th and 12th. This chapter is very important for examinations, and without understanding the concept of limits we can't do any questions. Therefore, let's start. Here is, if a function fx has a limit L as x tends to a, where x is a variable and a is a constant. Therefore, limit x tends to a of function fx equal to L. This means L is a limit of function fx and is given x tends to a. What is the concept of x tends to a? And without understanding the concept of x tends to a, we can't do, or we cannot understand properly the limit. Therefore, first we study what is the meaning of x tends to a in the function fx. Therefore, first meaning of x tends to a. X tends to a means it is read as x tends to a. X tends to a, read as x tends to a. This means x takes values closer and closer to a. And second point is that x tends to a, distance between x and a, distance between x and a is very small, means as small as possible. Means x tends to a, between x and a it has a distance, and distance will be very small as you possible, means you have possible. जितना कम हो सकता है उतना कम x tends to a पे distance between x and a will be. And third is point, either x less than a, this means x less than a, or x greater than a, but x not equal to a. Here is given three conditions. Number one, either x less than a or x greater than a, but x not equal to a. Let us start all these 3 points separately. First we take x less than a. What is the meaning of x less than a and how to represent in limit x tends to a of fx equal to L. Therefore, x less than a. What is the meaning of this? After that, we study it. The second point, meaning of x tends to a, it will be x tends to a minus, that is x less than a. That is x less than a. That is the first condition. Read as x tends to a minus. This means what? This means what? X approaches to a, x approaches to a from left of a. By graphically we show here this is a. We know that this is a number line, and from a this side will be positive number and this will be negative number, means less than a, and here is x greater than a. Therefore, if you take x here, x is going to closer and closer to a. This means x less than a means x is going to closer and closer to a from left sides. If x is here, this goes here, after it goes here, after it goes here, after it goes here, and at last it goes here. Therefore, the distance between this and this point, it will be very closer, means very small, is very small as possible. In this condition, x less than a or x tends to a minus. If we take a value of a 2 and x, if here is a point, that will be 1.7. Therefore, there will be after that it will be 1.8. After that goes 1.9. After that 1.99. And distance between this and this is the gap, and this is the very small. Therefore, this distance between x and a will be very small as you possible, and 1.7 increasing from the left, and will be goes to near to 2. Therefore, in this condition, x less than a or x tends to a minus. And limit of this condition, there will be, we can write x tends to a minus of fx is equal to let L1. In this condition, we can write the limit of fx as x tends to a minus will be L1. Clear? Therefore, we can write as, in this condition, we say that x tends to a minus fx has a limit L1. Therefore, we can write as in this form. Therefore, this is the condition of x tends to a minus. After that, we can study in the third point meaning of x tends to a plus, and there will be x greater than a. X greater than a. Therefore, x tends to a plus. And x approaches to from right of a. In this condition, if you take on this graph, there will be x tends to a plus. Therefore, x is coming from right side nearer and nearer to a. If we take the value of x is here, let 2.9. After that, it will be closer and closer, closer and closer, comes and near to a. And if a equal to 2, therefore at this point it will be 2.01. From this, here is the greater value, here is the greater value, but both value are greater than a. Therefore, we can say that here is a plus. X tends to a plus, and x come from right to near a. In this condition, x approaches to a from right of a, and this will be distance between x and a. It will be very small as you have possible. Therefore, we can write as limit of x tends to a plus of fx equal to L2. Let. What is the value of L2? L2 is the limit of function fx x tends to a plus in this condition, but not x equal to a. X not equal to a. Only going to nearer a. This limit is known as a right hand limit from a. It is clear? After that, we will study here existence of limit of the given function. We will study here after that existence of limit of a function. It had two conditions. Number one, right hand limits. Right hand limits, and it will be limit x tends to a minus plus of fx. Let it will be L1, and second, left hand limits, and denoted is limit x tends to a minus of fx. Let L2. If right hand limit and left hand limits both are equal, therefore L1 equal to L2. L1 equal to L2. If both are equal, therefore both limits are exist. In this condition, L1 equal to L2 means right hand limit and left hand limit, if both are equal, that is right L. therefore limit exists in right hand side and left hand sides. Therefore this is the first condition. And limit does not exist if limit does not exist if L1 and L2 not equal to. If L1 and L2 not equal, therefore limit does not exist. We cannot find the limit of the function fx. In this condition, if limit exists, we can write as limit x tends to a minus of fx is equal to limit x tends to a plus of fx is equal to limit x tends to a of fx equal to L let. Means left hand limits of fx, right hand limit of fx, both are equal, therefore the real limits of fx will be L. And in these conditions, limit exists in both sides. And this is not equal, therefore we cannot find the limit and we can say that limit does not exist. Again, if left hand side and right hand side limits are equal, therefore limit exists and we can find the limit of the function. And if both are not equal, therefore limit does not exist and we cannot find the limit of this function. Therefore, it was the basic concept of limits, and I have given the best for you. If not subscribe my channel, then subscribe, like and share. Next topic will be different types of formulas of the limits and properties of the limits. Thank you for watching.